Okay, good morning. I'm taking you through trade theory under the topic of SG generators, and it's just a continuation. I know we had done the previous parts in the earlier. So in today's session, we shall be looking at how to draw a sine wave. We are going also to learn on how to label the parts of a sine wave. And the last thing that we're going to do is we're going to apply the waveform formula to solve practical problems. So very first, let's look at a sine wave, how it looks like. So this is a sine wave. This is an alternating sine wave. It's also known as sinusoidal wave. It keeps on alternating, keeps on changing direction. As you can see from the graph, it is moving up and down in a pulsating manner. So in this graph of ours, we have several parts of a wave. That is a sine wave, and we have crest, we have trough, we have amplitude, and we have wavelength. And as you can see, trough here and amplitude, we are going to amplitude, we are going to define them by their definitions and see what they are. So very first, let's check on them. And the first definition is amplitude. And amplitude is the maximum distance or height the wave attains. And as you can see from our graph here, this is the height or the maximum height this wave attains, and we are calling it amplitude. Let's check on the second definition. The second definition is wavelength. And wavelength, we are saying that is the distance between two consecutive crests or troughs. Let's check on the graph. The distance between two consecutive troughs or crests. And it is from this distance here to the next distance here. We can also say that a wavelength is the distance between one trough to the next trough, one crest to the next crest, or from one trough to the next trough. Thank you. We are going to focus more on wavelength later on in so as to achieve our third objective. So let's look at crest. And crest, it is the highest part of the wave. Crest is the highest part of the wave. This tip here is what we are calling crest. And obviously, trough now becomes the lowest part of the wave. The lowest part of the wave, as you can see from our diagram. Now we are going to look at the formula that is used to calculate wavelength. As we have said that wavelength is the distance between two successive crests or two successive troughs. That distance in between is what we are calling wavelength. So wavelength is given by abbreviated or symbolized by a symbol known as lambda, and the spellings are here for the word lambda, which is given by velocity, what we are calling the wave speed or velocity, and it is measured in meters per second, divided by frequency of the wave. And frequency, we said, is measured in hertz. If you can recall from the previous unit, whereby we were discussing about electrical quantities. So we have said that wavelength is abbreviated as lambda, and this is the symbol for lambda, which is given by velocity or the speed of the wave divided by frequency. We are going to look at the first example, or not. So these are simplified formula whereby we have said that wavelength is given by wave speed or the velocity divided by the frequency. So ensure you memorize on this formula because you're going to apply it to various examples. So this is our example number one. Let's try to apply the formula that you have learned on how to calculate wavelength so that we can use in this problem. The question says that light travels through water to about 225 million meters per second. If the wave frequency is 4 multiplied by 10 raised power 14 hertz, what is the wavelength? Recalling our formula whereby we have said that wavelength is given by velocity divided by frequency. So what do we have from this question? We are already given the velocity or the speed of the wave, and the speed of the wave, it is here. That is 225 million per second. We can try to simplify this by using 10 power factor, that is 2.25 multiplied by 10 raised power 8 meters per second. That is our wave speed or velocity. The frequency also is given. We have been told that the frequency of the wave is 4 times 10 raised to power 14 hertz. And we say that wavelength is given by velocity of the wave or the wave speed divided by frequency. Therefore, our lambda will be given by 2.25 multiplied by 10 raised power 8 divided by 4 multiplied by 10 raised power 14. Let's check our calculators. If you take your calculator and divide, you're going to get your wavelength as 5.63 multiplied by 10 raised to negative 7 meters. I hope you have understood on that. Let's look at the next example, example 2. In example 2, the question said that find the frequency of a wave with the wavelength 2.5 meters and a speed of 50 meters per second. So this question here is asking us to calculate frequency, and we have been given wavelength and the speed of the wave. Therefore, frequency, using our formula here, this is our formula. So we need frequency. How are we going to get frequency from this formula here? How are we going to calculate frequency? If lambda is given by voltage divided by frequency. So what is frequency? Frequency will be given by velocity or the wave speed divided by lambda or the wavelength. So this is our formula. Frequency will be given by the wave speed or the velocity divided by the wavelength. And our wavelength, our wave velocity or speed is 50 meters per second. This wave is moving at a speed of 50 meters per second. And the wavelength is 2.5. Sorry, this is supposed to be 2.5 meters. There's an error here. So our frequency will be given by, if you divide this, you can multiply by 10 here to remove the decimal, then multiply again here by 10. So we shall have 25 divided by 500. So by 5, we shall have 5. By 5, we shall have 250. 250 divided by 5, we shall have shall go 20 times, and therefore our frequency will be given will be equal to 20 hertz. I have an assignment for you guys so that you can be able to understand this concept further. So the assignment for you is here. We are supposed to calculate the wave velocity given that the wavelength is 100 kilometers and the frequency of the wave is 15 hertz. So please do that assignment and let's meet in the next lesson. Thank you.